Hey guys, this is going to be part one or lesson one of the solar system and the universe. I'm either going to be looking at the screen or down in my notes, so if my eyes are elsewhere, it's okay. So, this is what the program that I'm going to be using. It's called Screencastify. Basically, you can see on my screen, and also I'm down here in the corner teaching, just so you can see me. So this is a Google slide, and this is the same Google slide that is on the Google Classroom page. So if they need to go back and review or anything to that nature. So we're going to be learning about the solar system and the universe. And most of this stuff will be reviewed, but we're going to go more in depth in certain areas. So let's go. Okay, the first lesson we're going to do is what objects are part of the solar system. It says the sun, Earth, and its moon form a system in space. Earth revolves around the sun. That means Earth travels around the sun in a path called an orbit. The moon revolves around Earth. So that is what we're going to be learning about in lesson one. We're going to be learning about all the things that are floating around in space. And just to give you a just a little note, they don't say they call them objects. They don't necessarily call them planets or moons or whatever. They say objects. So that's when you hear that word, it could be anything. Okay, the solar system. Earth and its moon are part of a large system called a solar system. Our solar system consists of 8 planets. When I was growing up, it was 9, but they declassified Pluto. I still count it though, but it's 8 planets, and we are all part of what's called the Milky Way Galaxy. It's like the candy bar of the Milky Way Galaxy. A solar system is made up of a star, which our star is the sun, and the planets and other space objects that revolve around that star. So you may not think of it, but the sun is a star. It looks so large to us because it's actually the closest star to us, believe it or not. A planet is a large round body that revolves around a star. And once again, our star is the sun. When astronomers, and we're going to talk about that here in a minute, started studying about space, they thought that everything revolved around Earth. But smarter people came along and said, no, we revolve around the sun, which is our star. So the sun is the center of our universe. Okay, I'm going to move my picture out of the way here. Okay, you need to know this, and it's going to come back for us. What's the difference between rotate and revolve? If I was in the classroom, I'd actually be up moving around, but when you rotate, it's kind of like if you think about rotating your tires, it means that you're just spinning. It's just like you have a ball and you're just spinning it round and round, okay? It's going to rotate on what's called an axis, and basically the axis are the 2 points that keep it steady. It's kind of like if I had 2 strings, one on each side. That would be the axis. And it's just moving on its axis, okay? Now, when we talk about Earth, that is 1 Earth day, 24 hours. That is rotating. You're just moving. You spin around and around and around in your chair. That's rotating. Then you have revolve. Revolve's the bigger one. It means that you're actually making a complete revolution around whatever object. It's kind of like if I was standing right here and I had people moving around me. They are revolving. Now, when we talk about Earth, it revolves around the sun, and it takes 365 and 1/4 days, to make one complete revolution around the sun. That's our 1 year. And this year was 2020. That actually gave us a leap year because if you remember, I said 365 and 1/4. So every 4 years, we get an extra day, and they put that into February. So when we rotate, you're just spinning on your axis. When you revolve, you are moving around. Okay? Rotate, revolve. Okay, that's something we need to remember. Okay, move myself back. Okay, the Earth's moon. Moons, believe it or not, are what we would call a satellite. Moons are small natural objects, which we refer to as satellites, that revolve around another planet. Now, they don't meet the criteria for a planet, so they're called a moon. And also, why they're called moons and not planets, even though some of them are bigger than some planets, is because they don't revolve around the sun. They actually revolve around the planet. But you're like, Miss Moore, they are revolving around the sun. Yes, they are revolving around the sun, but they're in the gravitational pull of that planet that is in the gravitational force of the sun. So the moon belongs to the planet, not the sun. Now, Earth only has one moon, but we're going to see a little bit later, some planets have several hundreds of moons. But luckily for us, we only have one. And our moon has a 27-day lunar calendar. That means it takes 27 days for the moon to make a complete revolution around our Earth. And that also explains why we have moon phases. So our moon, we only have one, and we only ever see just one side of this moon. We never get to see what's called the dark side. So the moon, we have one. Some can be small, some can be large, but they revolve around a planet. It's not going to let me click my mouth anymore. Okay. Stay. All right, orbiting. When you are orbiting, your parents probably think you're orbiting around them right now, being at home all the time. But when you orbit, the orbit of our planets are not in a perfect circle. Some of y'all, when we draw how the planets are, we usually do it in like little circles. And you're going to see a picture on one of the quizzes. It looks like a perfect little circle, but it's not. If you can look at the picture right here, you actually see Mercury starts its revolution right here. And as you can see, as it moves, it's not a perfect circle. They usually are elliptical, and it kind of looks like an egg almost if you look at it. But it has a path that it takes, and it takes this path all the time. So all planets, they don't go in a perfect circle, and they don't stay on that perfect circle. They have more of an elongated path, and they stay on that path. And that is actually one of the criteria to be classified as a planet. And we'll get to that here in a little bit. All right, planets. Planets. You should already know most of the planets. Actually, you should know all the planets, but there's a really it's a really easy statement. My very eager mother just served us nachos, and you have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. So just served us nachos. So, next slide. Okay, what is a planet exactly? Well, according to the International Astronomical Union, somebody's in the kitchen, which sets definitions for planetary science. In 2006, they actually redefined, and this is why Pluto got kicked out, a planet as a celestial body. Celestial means space. That, number one, is in the orbit around the sun. Number two, has enough mass to assume a nearly round shape. And then number three, and this is the one that got Pluto kicked out, has cleared the neighborhood around the orbit. That means it has a set path. What happened with Pluto is that it actually would go into Neptune's path. So in 2006, it got declassified as a planet. So that's what a planet actually is. Okay, with our planets, we are put into two categories. It's either an inner planet or it's an outer planet. And the planets are actually separated, the inner and outer, by the asteroid belt. So it's a pretty good divider there. The four inner planets are the closest planets to the sun. The inner planets are dense, which means they're tightly packed in, and they're rocky. These planets are known as the terrestrial planets. The inner planets are very small in diameter. That means across, they're very small. It's kind of like if you were to compare the softball to one of those big kickball things that you find at Walmart. This would be your four inner planets, and the bigger, even a basketball, would be what you would classify as a outer planet. And the outer planets are the ones that are furthest away from the sun. You have your inner planets, and then you have your asteroid belt, and then you would have your outer planets. The outer planets are huge, and they're composed, which means made up of mostly of different gases. This is why they're called gas giants. Outer planets do not have a solid surface, and their cores are very small. When it means a solid surface, it's kind of like when you have Earth, you have our ground, and it's a solid, rocky surface. The outer planets don't have that. Okay, our inner planets, you have Mercury. Mercury is the smallest planet in our solar system. It's the closest one to the sun. You have Venus, which is composed of a thick cloud, very thick clouds that cover the planet. They're composed of CO2. That's usually why it has that orangey, rusty color. And then, of course, we're very familiar with Earth. Oh, CO2 is carbon dioxide, I'm sorry. Earth is the only planet that's known to have liquid water, which allows it to support life. And then we have Mars. Mars is known as the red planet. It's just basically a great big dust storm in space. So those are our four inner planets: Mercury, Venus, Earth, and Mars. Mercury, Venus, Earth, Mars. My very eager mother. Okay. Mercury's our smallest. Venus is just a big cloud of carbon dioxide. Earth is the only planet with liquid water and life forms. And then you have Mars, which is our red planet, which is a great big dust storm. The outer planets, which are also known as gas giants, you have Jupiter. Jupiter is known as the planet with the great big red spot. That's just basically a big storm that's been going on for centuries. Saturn, most people equate Saturn with the rings, but it's not the only planet with rings, actually. But it's made up of thousands of little rings on the outside that's made up of ice and chunks of rock around it. Now, I pronounce it Uranus. Some of you may say Uranus, but it's Uranus. Uranus is actually, if you remember, I said you have your axis and it kind of does this. Like Earth is actually tilted a little and it spins like this. Uranus actually got hit, they say, like a long time ago. It actually kind of spins sideways. So it spins like this. So that's one thing that a lot of people notify that at. And then you have Neptune. Neptune is actually, believe it or not, the windiest. And when I was doing the research, it said it can get up to thousands of kilometers per mile, which would be thousands of miles per hour in the windstorms. And it also has a great dark spot, but you have your Neptune is far out. Now, if you're familiar, you also know like Jupiter, Saturn, Neptune, Mercury, Venus are also names of, you have Greek, and then it ties in with Roman mythology. So that's where a lot of the names come from. And that actually will come back to us when we talk about constellations. Okay. I don't know what's going on here. Oh, okay. This was the chart, and you may want to pause the video and you can look at this. It's just some information. It tells, if you look right here, it's going to tell us how many days it takes to revolve around the sun. And as you can see right here, the closer it is to the sun, the shorter the year is. So you have, it only takes 88 days on Mercury compared to 225 to 365, and then you have right here. And as you can see, when we go out to the outer planets, it actually takes years. So we go from days to years. Now, when we say years, we're talking about Earth years. So like Mercury, it takes 88 Earth days for it to go. Venus takes 225 Earth days. Jupiter takes 12 Earth years. That's how they're doing that. Period of rotation is 59 days. That means 1 day on Mercury is actually 59 Earth days, so it's a long time. And Venus is 243 in our 1 day. That just means Mercury and Venus are spinning very slow on their axis compared to what Earth is. Mercury, this little symbol right here means about, so we're spinning at about the same rate. And then our outer planets, they're spinning pretty fast. It only takes 10 to 16 hours or 17 hours on there. And here we have some temperatures. These are temperature ranges. So believe it or not, Mercury, it depends on which side you're actually looking at. It can be a negative temperature. This is Celsius, which is most scientific area, but I'm going to do Fahrenheit right here. You can go from all the way to 279 negative all the way to 800. It just depends on which side you're looking at. Venus gets very hot. Earth, of course, we know like you have a negative 126 degrees Fahrenheit all the way to 136 in the Sahara Desert and places like that. Mercury, you're going to notice that as we get further out, the colder it gets because it's getting further away. So it can go all the way to, this is supposed to be a negative. Oh, my bad. That's my fault. So it can go all the way to a negative 357. Like, as soon as you stepped outside, you'd be in trouble. Number of moons, as you can see on our planet, Mercury, Venus doesn't have a moon. Earth has 1, Mars has 2. Jupiter has 67, and Jupiter has one of the largest moons. And it's stuck to Jupiter because it's in its gravitational force, even though it's very large. That's why it's considered a moon. Saturn has 62, Uranus has 27, and Neptune has 14. Density, that just means how packed it is. And as you can see here, these inner planets are very dense. They're rocky. And then you have these down here that are not. And this just tells how wide our planet is. If you have a circle, it's called a diameter. You have a circle, and it's from, well, like if I do this little piece of paper right here, it would be a circle. You'd go from this point all the way over to that point. That's what the diameter is. And as you can see, the diameters actually increase from this point. So you can see right here, Jupiter is our largest. And then you have Saturn, Uranus, Neptune. You go on between Earth, Venus, and our smallest, like I just said, is Mercury. So if you want to take your time to look at that, you're more than welcome to. Okay, so that is the solar system. We have the Sun, Mercury, Venus, Earth, Mars. We have a asteroid belt that goes here. Jupiter, Saturn, Uranus, Neptune. Now, we have flying objects in the sky, and like I said, they call them objects. They don't just refer to them as, or they'll call them bodies, because they really can't just, they don't know what it is at first. So besides planets, there are many other bodies orbiting the sun. These bodies cannot produce their own light, but shine by reflecting the sun's light. There are 5 technical ones. They're called asteroids, comets, dwarf planets, meteor, and meteorite. It's the same thing, but they're different names as different stages as they come into Earth's atmosphere. And we'll talk about that. And then you have moons. So those are the bodies that are in space. Now here's just a picture that helps. Okay, you have a comet. One of the things that defines a comet is the dust tail. Now, the dust tail that you see in a comet is actually, you have particles and stuff that is in that area, and it's reflecting the sun's heat, and everything reflects off of it. That's how you get the tail. It's a mixture of ice and dust, and it has an elliptical orbit. You can actually look, and there's a lot of GIFs and videos that it just makes a long little orbit around and the tail actually moves as the comet goes. All right, so this is where you get your asteroid. Asteroids are large, and if you know Star Wars, you know like the things usually hide out in the asteroids, and you know how close they are in the movies. They're actually not that close. They're very far apart. Asteroids are large, and they're usually stuck in a gravitational pull between the inner and outer planets. All right, now this is the part where the different names mean something. Okay, when you have a small piece, something that's smaller than an asteroid, that's traveling in space, okay, it's called a meteor. It's called a meteor. Meteor, yeah. No. Yes, a meteoroid. I'm sorry, I get these mixed up. It's called a meteoroid. Okay? Now, that's the small object in space. Now, when the meteoroid starts to fall, okay, and it gets into where we can see it on Earth, and it has like a little tail, and you see it, we call it a shooting star. That's when it's a meteor. Okay, it's a meteor, and then when it hits the ground after most of it's burned up, it's called a meteorite. So you have a meteoroid that's floating in space, minding its own business, and then it turns into a meteor when it gets into the Earth's atmosphere and gravity is forcing it down. And then when it lands on the ground and you have like this rock, it's called a meteorite. So there's meteorites all over Earth still because they've happened. So we think of these as shooting stars, but they're actually a meteor. And then you have your meteorite when it hits the ground. Now that was 16 slides on the lesson 1. We talk about our planets. We talk about the different bodies in space. And if you would like, you don't have to, there is a 5-question quiz. It's real easy. It came out of the same book that some of your other stuff in science came out of. And like I said, feel free to, you can look at where you can print out the power. I can't talk today, and I'm sorry. Where you can look at it. You can look at it as you take the quiz. If you need to go back, pause the quiz, have one tab open, one tab closed, it's fine. I just want to make sure that you're getting something while we're out, okay? So I will post another video with the second lesson, and we will go from there. So I will see y'all. If I can find out how to exit off of this, I will see y'all later.